should have ended that last video with the fifth step, so we'll start with the fifth step. There is a fifth step to hypothesis testing. It's the reflection on statistical practices. We ask the questions, how was our data collected? Is it random, right? Is it independent? Is our sample size large enough? These are the same questions we asked in previous modules. And then, of course, after you've conducted your analysis, we then ask ourselves, are there other questions we want to explore? What's going on, right? So don't forget the fifth step. It's actually an important process because if something's wrong with the data, how it was collected, then the results don't mean anything. If the sample size is not large enough, then what conclusions can we draw from the data? And then, of course, what do we learn and what do we want to know? What questions do we ask? So that's the fifth step. Now let's take a look at actually how to calculate. Now, this is how you calculate a test statistic right here. Okay, and so you can see an example. It looks more complicated than what it is. We have a scenario where we're trying to see, again, remember this idea that you're trying to see if you have enough votes, you have enough people to vote for you. You collect some sample data, ask 500 people, 51.6% say they'll vote for you. Is that enough evidence to say that more than 50% of the population will vote for you? And so that's what we do. We say P is equal to 50. That's the null hypothesis. Do we have evidence to say that P is actually greater than 0.50? Well, we have sample data that shows it kind of could be, but then we have to do the analysis, our variation, calculate the test statistic. How far is this? Is this far enough away from 0.50, right? Look at the subtraction divided by the standard error, the P's times the Q. Remember, Q is 1 minus P, and you get 0.76. So this is your test statistic. We then use that to calculate the probability value, the p-value. Well, this goes back to module 7, and you calculate the probability, since this is a greater than, the probability that x is greater than 0.716, because that's your z-score. What's the probability of a z-score greater than that? 23.7%. That's not a low value, right? And so then that allows us to, but we would use the ARTISTAT to calculate this, and the normal calculator, the standard normal calculator, because it's a z value, and then you calculate that probability. You will see some videos in our online homework that will help you with some of these calculations too, so keep that in mind. Now let's look at another example here. That same one about shooting percentage. So if someone shot 50 times, hit 74, is that enough evidence to say that it's not equal to 85? Well, the sample data is not equal to 85, right? However, is it far enough away? Because this is just sample data. If you shot again, what would happen? If you shot again, remember there'd be variation in that. So calculating the test statistics helps us anticipate or measure what that variation would be based off our knowledge of distributions, proportions, and distributions of means. You calculate, get a z, and you get negative 2.18. Again, using the p, 15 is 1 minus q. And you get a p-value using the standard normal calculator on the ARTISTAT, using mean 0, standard deviation 1, and then you plug this in here, and then you get a p-value of 0.0249, which is small. A small p-value. It's low. It's less than our 5%. So keep that in mind as we think about it. Here's a full example. Oh, right here. Here's a full example. You can pause and take a look at this full example. Notice the sample data. We're measuring to see how far that sample data is from the mean. I'm sorry, from the proportion that we said, which was that it equals 60%. We want to know if it's not equal to 60%, the sample data. Is it far enough away? Do the calculation. You get a p-value. And then we come up with our conclusion. And remember, this is a straightforward way of doing it, right? This is what we write this conclusion all the time. And then there's some notes here about how to do it. Since the p-value is less than alpha, our p-value, very small, it's less than, or level of significance, which if it's not stated, we assume 5%. And since that's the case, we go back to that table, and there it says there is sufficient evidence that the proportion of graduates who are prepared has changed, right? Because it's different than the 85%. And again, make sure you review the online homework. There's posted videos in there that further show you how to use the ARTISSSTAT to kind of manage hypothesis testing. This is not in any notes. This is just in an extra example I did in my in-person class that may be helpful. So I'm just going to pause and you can take a look, see as a practice problem. You could see if you can match that up, but I'll leave that there real quick. I'm not going to explain it since this is not part of any of the notes. It's just a practice problem, and maybe you could see if you can match it up yourself using what you know.